So I called this lesson 6.05. The last lesson was lesson 6.0. We haven't actually started the new unit. This is some preamble that I wanted to make sure you understood. I called this using a graphing calculator. I listed a few common things that you might want to know. Of course, as soon as I start, someone's going to come late. Let's see. Continuing on. To delete an equation, if you get an error, there's some instructions here. You know what? We're going to kind of just jump on in. So get your graphing calculators out. You have your graphing calculator here, I hope, because that's what today is about. Example 1 says this. The profit of a party is related to the number of people attending by the equation that there. I see two variables in that equation. Which of those do you think refers to profit? P. Which of those do you think refers to the number of people? N. Now we're going to have a limitation with our graphing calculators. They are pretty much confined to y and to x. So even though in my equation I have a p here and an n here, on my graphing calculator it's going to be a y there and an x there, sort of in that y equals mx plus b format that you're used to saying. I wrote here, assume the maximum number of people that can attend is 50. Okay. Use the table function in the calculator to fill in the table below. So turn your calculator on, press your menu button, and let's go to the table function. Now mine is option number 7. What's yours? Option number what? 5. So go find option number 5. You may have an equation next to y1. If you do, you'll have to press delete, which is F2, and clear any equations that you have there. You may or may not. I don't know who used your calculator last. Everybody got that okay? So we're going to type in this equation. So we're going to go 20. Instead of n, I have to use an x. My x button is just below the red alpha button right there. And I think that's where it is on yours as well. Take away 500. And then enter to store it. Okay. So far, so good. Does your menu say select, delete, type, style, set, and table? Okay. We need to set the table, no pun intended, which is F5. Says start with what? Look at my table that I actually put in our notes. What's the smallest n value we want to start with? 0. So let's put a 0 there. What's the biggest n value we want to end with in the table in our notes?
40.
Sorry? 40? Let me pause. Are you guys there? Christina, you there? Hang on. Okay, you guys set the table? Yes? Anybody else said no? We're there? Okay, 40. And step is what you want the table to go up by. Look at my chart. What am I going up by? 5s. Okay? And then if you hit execute again, it takes you back. Or you hit enter twice, takes you back to here. And then to view the table, press F6. Got an error? Okay, let me pause. My guess is you hit negative instead of subtract. So let's fill in the table. It looks like when n is 0, profit is we're going to lose $500. If 5 people show up, we're going to lose $400. If 10 people show up, we're going to lose $300. Someone else showing up late. Let's see, when x is 15, negative 200. I guess I can go down arrow. 20, negative 100. 0, and I guess I could also spot a pattern. 100, 200, 300. Is that right, Mr. Dueck? Yeah. Is that okay so far? So you can enter a table, and it's pretty easy to tell it where you want the table to start at, what you want it to go up by. Some of you may find this handy if you're in camera biology or physics or something like that as well. We can also graph this. So if we go menu, and now go to your graph menu. For me, my graph menu is menu number 5. What number is your graph menu? So go to menu 3 for you guys. And conveniently, it's already put that equation there. But what I need to do first is I need to tell it where I want it to graph. I have this small rectangular screen. Anytime I graph anything, I need to tell my calculator what dimensions I want it to display on the screen, where I want it to zoom into. And to do that, we need to change the view window. How do we change the view window? If you look at step 5, when you're in graph, it's Shift and then F3. Your view window may have other numbers there, so get into the graph menu and then Shift F3 to change the view window. Okay? With me so far, Sean? Good, good, good. And what I said is I'd like your minimum x value to be 0. That's how I'll write it. What do I want your maximum x value to be? 50. Scale is what you want each hash mark to be worth. Now, my screen is only this wide, and I'm going to go from 0 to 50. I don't think I want to go up by ones, because I'm not even going to be able to tell that apart. What would be a good scale to have my calculator go up by horizontally here? 5? Sure. Now, if you do that, does yours have the dot thing or not? Yours does? So what it's telling you right now is what each pixel is worth. Don't change that one. Scroll down. What's the minimum y value I want to appear here? Negative 1,000. What's the maximum y value I want to appear here? Positive 1,000. Now, no. X min, X max, Y min, these are not coordinates. These are not points. That's why I'm using square brackets. This is how we display a view window that I want you to do on your calculator. It's always going to be X min, X max, Y min, Y max. I did not use curvy brackets on purpose. Okay. If I'm going from negative 1,000 to positive 1,000, do I want to go up by ones? That's going to be really awkward to read. What would be a good scale vertically? 5s would also be a bad scale. What would be a good scale that would kind of make sense vertically? There's no wrong answer. Well, I guess there is, but 50, 100. Yeah, I'm going to go by hundreds. Each hash mark's going to be 100. That there, I have no idea what it is. Leave it. Okay? We have changed our view window to match the parameters that they gave me in these square brackets. So now if I hit exit, that's this button here, and draw, oh, condition error. Did I type something wrong, Mr. Dueck? 0 to 50. I don't want any of that. 0 to 50, scale 5. Did you guys get an error? Draw. Bear with me. There's something wonky on my calculator. Nothing down there. Yeah, mine's weird. Yeah, hang on. I'll get to that. Pause the video. Okay, I figured out what was going on. It accidentally deselected the graph. Now if I hit draw, you should get something like that. If you're not, now is the time to call me.
How do you draw it?
Okay, hang on. Draw. Okay. Now, what was your comment? Doesn't have like a horizontal line to it. Okay. Let me come look at your calculators. This is always painful the first. So I think we've got all the glitches fixed. Here's what I want you to do. So Jacob, to show you a view window, I'll almost always use square brackets. If you're referring to a graph in your solution, one of the things I'm going to need you to do is to tell me your view window. And the way you'll do that is underneath your sketch of the graph, you'll just write your x min. Now we said it was 0 50, negative 1,000, 1,000, and the graph looked kind of like that. I'm a little bit off. I think mine actually crosses dead center. Fine, I'll try and be a bit more accurate. Cross right about there. Someone asked a question? I don't know. What did I put here? That's what I'm saying is if you're giving me a graph solution, you need to tell me somewhere what your view windows are so I can recreate it on my calculator. Assuming I have a calculator. Okay? Then I wrote here, part C, find the number of tickets that need to be sold in order to break even. Where do you think that is on this graph? Where's the break-even point? The middle. I need something in terms of the graph and some math words. Kayvon. Okay. So we call that an x-intercept? Yes? So you can draw a little arrow right here. This is called an x-intercept, or the fancy word for this, we also call them roots. These are the roots of the equation. So you can find the root of an equation. Now, I know what the answer is from my table. It looks like the answer is going to be 25. But if I didn't know that ahead of time, I could find that on my calculator. So if you go to your graphing calculator, we want to do some graphical solving. Look up. Just keep looking up for a second. We want to do some graphical solving. We want to do some graphical solving. It's G-solve, which is F5. If you press, all of you right now, F5, if all of you right now press F5, you'll find that you can find a root. You can find a maximum, that's the highest point on a graph. You can find a minimum, that's the lowest point on the graph. What do you think y-iskt stands for? Y-intercept. What do you think iskt stands for? Give you a hint. We can't do it right now because we only have one equation on this graph. Okay, it stands for intersection. If you have two graphs, you want to find where they cross. Arrow sideways, there is more that you can do. You can do a y calculation or an x calculation or from calculus an integral. Meanwhile, though, we want what? The x-intercept. And what's another word for x-intercept? Press F1. So, how many tickets need to be sold in order to break even? 25. Give the domain and the range of the function. Now, the domain and the range of this function are going to come from my original instructions. What's sitting where the x remember, domain is your x variables, how far left, right. Range is your y variables, how high up, down. What's sitting where the x variable is in my equation, though? And what's the smallest number of tickets that I can sell? 0. What's the maximum number of tickets that I can sell? So the domain, well, don't write this down. Don't write this down. Don't write this down. That's what I want to say for my domain, but that's way too much writing. Okay? That's way too much writing. So I'm going to erase that. How could I write that? Well, you may have learned way back, way back in Math 10 that you could go like this. 0, 50, touching, and touching. That's everything between 0 and 50.
Write this down?
Write that down. Or the other way you may sometimes see this written, you may have seen it written that way. Everything between and touching 50. What would the range be? Well, range is profit. What's the lowest profit I can make? If I sell no tickets, how much money do I owe? Sorry, not 1,000. 500, negative 500. And if I sell 50 tickets, what's the maximum I can make? Because I said the max I can sell is 50. That's what this hall holds. Well, there's a couple of ways to do that. I could plug in a 50 into this equation. Or, hey, press G solve again. Press G solve again. But this time go arrow sideways, which is F6. I'd like it to do a Y calculation for me if I tell it an X value. So press F1, and the X value, I want to find the Y value that goes with an X value of 50. Oh, looks like 500 is the maximum profit I can make. So it looks like my range, if I sell no tickets, come on. Come back here. Looks like my range, if I sell no tickets, I lose $500. If I sell all 50 tickets, I can make $500. Or, sorry, negative 500 less than or equal to Y less than or equal to 500. I said use the table function to find out how many tickets need to be sold for a profit of $2,000. Let's suppose we can rent a bigger hall, or let's suppose we need to make $2,000 and we need to say, okay, how big a hall do I need to rent? How can I figure that out? Again, I could do this algebraically. I could put a 2,000 right there, and I could solve for n. Plus 500 divided by 20. I could do it algebraically, or I can try my table feature. Let's see, if I go to my table feature, so Kayvon, we're going to go back to menu. This time we're going to go back to our table. And let's see if it will let me put a value in for y. I don't know if it will. Can I type a 2,000? It won't. Let me see here. Let me see here, Mr. Dueck. Let's go back to setting the table. And instead of ending at 40, let's see, hey, maybe 100 people. I'm just guessing. Okay, so we set the table. This time I said stop at 100. And now if I go table, let's see if I can see how much I want to make, $2,000. Will 100 people get me there? No? Okay, let's guess again. Exit. Set the table. Let's go 200 people. That should get us there. Table. You with me, Foster?
I can't find the set.
You have to show me? Gotta go. You're in the graph menu still. Gotta go back to the menu. Table. Gotta go to the table menu. Okay? You know what? 125 tickets will get me $2,000 profit. Are you in the table menu? Okay. So right there, set. F5. Okay. Anybody else?
What were the numbers?
I went to 200. I tried 100 first. That wasn't far enough, so then I doubled it and I said, I'll try 200. It was just guessing. Okay, but then 2,000 does appear, yes? Scroll down. Anybody else? Make sure you're in the table menu. Anyone else? Okay, I'm going to write down, first of all, was it 125 tickets? Brooke, you got it okay, kiddo? Okay, let me come there. Sorry? Yeah? Turn the page. Example 2. The height of a rock as it is catapulted off of a cliff is related to time by the equation h equals negative 4.9 t squared plus 110 t plus 240. This is going to be a curve. How can I tell just by glancing at this is it's going to be a curve? It's got squared. In fact, it's going to be a parabola. In fact, you guys should know it's going to be a parabola that opens downwards. How do you know this parabola is going to open downwards? Okay, the squared is negative. Those of you that are in physics, you may actually recognize d equals vit plus a half at squared, except I've written it as a half at squared plus vit plus initial distance, for those of you who are in physics. Use the table function to fill in below. So let's enter this. Let's delete the current function that we have. That's going to be F2. Make sure you're in the table menu. So delete, yes. Again, although my equation has an h and a t, I'm stuck with y and x. So I'm going to go negative 4.9. Now look up, please. I had a number of you use this. These are not variables. These are equations. Don't use these. Your x button is this one right here below the red alpha. X squared plus 110 x plus 240. Enter to store it. Is that okay, Justin?
Yeah.
Set the table. It looks like the minimum time value I have is 0. What's the maximum time value that I have in the chart for us to go with? Sorry? 24? And what do I want us to go up by? 3? We all there? I'm seeing a lot of confused grimaces. If you fall behind, please let me know right away, because I don't want to go 3 steps ahead. Then I got to recover you 8 or 9 steps. Continuing. Yep, we're there. And then hit table. We can fill in the values. So it looks like at time 0, how high are we? At time 0, how high are we? Those of you that are in physics, we would call this D0 or X0, position 0. This is your initial displacement. 240. After 3 seconds, how high are we? 525.9. After 6 seconds, 723.6. 9 seconds, 833.1. 12 seconds, 854.4. 787.5. 632.4. 389.1. 57.6. Is that right? Yeah. And then you typed your equation in wonky. Give me a second. Between what 2 areas do we reach the top? Look at the data. Between which 2 intervals do we hit the peak and start coming back down? Between what and what in terms of seconds here?
9 and 12.
Between 9 and 12? Between 12 and 20, we can be more specific than that. Am I going up between 6 and 9 seconds still?
Yes.
Am I going up between 9 and 12 seconds still?
Yes.
Am I going up between 12 and 15 seconds still?
No.
So it's possible it's between 12 and 15, although maybe I reached my peak like right at 11 seconds and was already on my way down, but I can't tell that from my data. I can tell you sometime between 9 and 15. To be more specific, I actually need the graph, which we're going to get to in a second. Have we hit the ground after 24 seconds?
No.
What would the ground say? Okay, so I just made a guess as I was roughly trying to figure out what the interval would be. If I want to find when I hit the ground, I'm going to have to graph this over a slightly bigger interval. In fact, here's what I've suggested. We're going to use the graph function, but we're going to go from 0 to 25 and from 0 to 1,000. So get out of your table. So you're going to hit Menu, Graph, which for me is option 5. I think for you guys is option 3. And before I hit Draw, I need to change my view window. How do I change my view window? It's right there. It's Shift F3. It's in yellow right above F3. And I'm going to go from 0 to 25. Sure, I'll still go up by 5s. And I'm going to go from 0 to 1,000. And I'll go up by 50s. I think I'll be able to see that. Okay? I see a lot of you copying off of me. Understand the view window's right there in front of you, right? That's the scale. Let me show you what I mean when I hit graph here. Okay? Condition error. F1. What I'm saying is this. Look up. Each of these is going up by 5s. That's how I put the scale. Look up. That's why I didn't want to go up by 1s. That would give me like a big blurry line down here. I wouldn't be able to tell them apart. Each of these is worth whatever I think I said my vertical scale was 50. So each of these is worth 50. I certainly wouldn't want to go up by 1s because that would just give me, if 1,000 little hash marks here wouldn't fit on my screen. It'd just be a big blur. So I'm not going to mark you wrong or right on a scale. I just try and pick something that I can actually kind of figure stuff out. And I got to fit 25 things in here. My area is this big on my graphing calculator. I don't want to 25 hash marks isn't going to fit. I just try and pick a nice number that roughly spreads it out. I went by 0 to 25s. I'll go up by 5s. I wouldn't go up by 7s, Rachel. That's a dumb number to try and keep track of. I wouldn't go up by 6.3s. 2s I would be fine with. 5s, 10s. Did I answer your question? I'm not sure I did. Okay. Anybody not get this graph? Sure, you can go up by hundreds. So hit enter. Okay. Anyone else? Okay, let's first of all do a little sketch here. So 0 to 25 is my X window. 0 to 1,000 is my Y window. My graph looks like it starts right about here, and it hits the ground right about there, so kind of, sort of like that. So far, so good? Okay. What's H want us to find? Maximum height? Hey, that sounds like it wants to do some solving with the graph. F5, hit G solve. If I want to find the maximum height, which button do you think I might want to use? Okay. By the way, what you're also doing is finding the vertex, and you learned a method, I think, last year of completing the square to find a vertex, a very complicated method. Turns out you can do it with software as well. I'm going to hit F2. Oh, there you go. What's the maximum height? Yeah, not 11.22. That's not height. That's your X coordinate. What's your height? The Y coordinate is the height, right? So what's the maximum height? 857.35, if I round off. When does it occur? At 11.2 seconds. So the maximum height, H equals 857.3 meters. T equals 11.2 seconds. What is, yep? You guys are the techie, pretty disjointed lesson with like 10 interruptions. But that's okay. Always happens with graphing calculators. J. What's J asking me to find? Where is that on my graph? Roy, what did we call that in terms of a graph? The x-intercept, and what did I say, the fancy word that our graphing calculator uses? Okay, find the root. Find the root. Brooke, need your attention span here. Find the root. Right, that's going to be the 0. So, boom. Hits the water, 24.45 seconds after launch. Okay. Yeah. Yep. Roy said, hey, Mr. Dueck, look up, look up. Look up. Hang on, I'll get you a second, Rachel. Roy said, hey, Mr. Dueck, couldn't I also go table and then just type in when x is 0? Well, no, that doesn't quite work, does it? I would somehow have to put a y value of 0. Pardon me? Actually, well, another way to do, probably, I think the easiest, though, is to use the root function. Okay? We also, Roy, because you're in physics 12, we could find this algebraically, right? You would let y equals 0, and you would solve the quadratic equation, which is really what this thing is doing, but a little quicker, a little more efficiently. Rachel, you had a question.
How do you find how long it takes to water it?
So where is that on the graph? Right there. What do we call that when it touches the x-axis? Yes.
So, like,
Right, it's the x-intercept, but this calculator calls it a root. By the way, the reason they call it a root is they're assuming that in real life you're not always using x's and y's. For example, in this equation, calling it an x-intercept would technically be wrong. It's a t-intercept. So the generic term for any intercept is a root. Being fussy, but I kind of like that. Any questions, some stuff there? Okay. We're going to be doing a little bit of an investigation. Okay? So here's what you're going to do. Each of you, or in groups of 2 with your table, is going to come up here. You're going to get a ruler. The rulers are on the table right in front of Sean. And you're going to get a piece of string with a pair of scissors. You're going to cut off a piece of string about yay long. The string is behind Jordan on the counter. What you're going to do is you're going to get the circumference of someone's neck, put the string around someone's neck, start out with your own, and then measure it on the ruler, how long that piece of string is. And then also you're going to get the circumference of the wrist, and you want to get a total of 14 people's worth of data. Okay? Wrist circumference. Again, don't clack, clack, clack with the string and choke somebody. It's just nice and loose so that there's no slack, but that there's no dent. Okay? Same for the wrist. You're all going to have slightly different data because you're all going to be picking different people, and that's fine. Then what you're going to do is you're going to graph the results below. Circumference of neck should be the domain, so neck is going to go on the x-axis. Wrist is going to go on the y-axis. Come up with a good scale. I don't know what your scale will be. It's going to depend on what values you have. But try and use a scale that uses most of the graph paper. Start just under the lowest value and go to the highest value. Your graph must have a title, domain and range titles, and cover about 3/4 of the grid. Then see if you can answer these questions. Also, your homework is attached. It's these assignments here. I haven't included the answers. We'll go over the answers tomorrow because this is using technology. So you have the remainder of class. You definitely want to get the data, the 14 measurements in the remaining 25 minutes or so. So let me pause the video.